Hello folks, my name is Saurav Datta and I've decided to make a video series starting from basics of electronics to all the sort of fun projects that you can do with the open source microcontrollers, not only just Arduino but even with just scrap electronics around you. So this whole series is meant not just for kids, say from 6 years onwards, not just for kids but for anyone who is interested in electronics, maybe doesn't have any idea in electronics but really want to start off with it. So and before I just start, I'm just going to tell I'm here at my room essentially. So this is not an office and I don't have much of the parts here, so I was just able to grab one fritzing kit this morning from one of the co-mentors of Hackademia. I don't have any other member yet who could just shoot the video and help me out here, but so please bear with me because it's going to be a bit shaky. So to start off with, I feel all of us should be introduced a little bit to basic electronics and bit of programming. So today in this session we're going to deal with introduction to electronic components essentially. Don't worry, I know this is not exactly a very fun thing to do, but please bear with me because this is actually going to help you for all the coming projects that we'll be doing and making in this upcoming series. So I have a maker notebook with me, and this is this plastic thing, this looks like a very thick mobile phone, but this is essentially called Breadboard. So when I was a kid, I was very interested in electronics and I never knew where to start from, but on the long run I just got myself acquainted with this whiteboard. It's called Breadboard. It was not even available at my place back then. So there was a physics professor in a college. I sneaked him to his room one day and I asked him all that I could ask, and he introduced me to all these things. As a result, I made my first working functional water sensor on a breadboard when I was in 8th standard, and then I moved on to soldering just after 1 year. So this is not essentially very hard to follow up with, so don't be afraid. The first thing you need to reject is the afraid of that everything is hard, some things are hard, you cannot get something. Today everything is possible, believe me. So this whiteboard is called prototyping breadboard. Why this is called breadboard, I don't know. Maybe because it's white, maybe because it has pores in it, but what it does essentially, it does act as a platform for testing and making your circuits at a preliminary level before you go on to soldering. So yes, so that is essentially it. Now if you just break open a breadboard like this, I haven't broken it up, but I have broken a couple, but I won't do it this one. I have just found a very good illustration in a fritzing book. If you just break open a breadboard, you'll see how the connections are made and how they actually help in fixing your electronic components. Essentially, these electronic components come in packages called DIP. So they have these pins in them. I'll just take an LED and I'll show you here. So this is essentially an LED and this has legs. So many components have 2 legs, many components have 3 legs. Don't worry, I'll just introduce to all of it. We're not going to make any circuits today, we're going to make it in the next session. We're talking about breadboard here. So yes, breadboards have the connections here. So if you could see, it's very clearly illustrated over here that everything here are made connected in this series. So F, G, H, I, J are all connected together. Then in the row 23 all these are connected together. In the row 28 all these are connected together. So these things are all shorted in this way. So just to give you more introduction, give you a bit better idea, now you have this is a small LED. I'll tell you what LED is. Just imagine it's a small electronic device with 2 legs right now. So you need to connect it to power sources. Now power sources also have 2 prongs with them. You literally don't want these two legs to short down. Now if anybody tells you how you connect an LED to a power source in a breadboard, you would definitely not like to do that in this way. Because here if you notice, both the legs are being pushed into the same series, into the same row 30, so that way they are both being shorted. Now if you want to put this LED onto this breadboard, you would really like to do that in this way. Put the legs in two different rows. Doesn't matter you put them as close or different, because they are not shorted. Row 29 and row 30 are not shorted. Similarly, row 28 and 29 are not shorted, but all these pins are shorted. Now if you want to put a wire from here and pull it to the power source here, then this whole row 29 gets shorted, and its whole row 29 will be having the power fed from positive. So yes, so this is essentially how and they have actually copper claddings and sort of hinge sort of thing, so that they can tightly snug those LED pins over there, whatever electronic pin legs you have that you want to push into the breadboard. So this is how the connections are made in breadboard. Also, if you notice clearly here, they have a middle sort of breakpoint into the whole board. This is essentially a mini breadboard. Breadboard comes in various shapes and sizes. Some comes in transparent mode, so if you could just bear some price, get it from SparkFun or some other place, you'll have a breadboard which is clear and you can see all the connections that are being made. So but I like this one because it's clean and white essentially. So yes, now I was talking about this breakage here. So why this is made, you see, as I talked about these LED pins here, you can literally put them in like this, right? Now say you have a IC, you have a IC with say 1 2 3 4 5 6 7 8. It is essentially a schematic of a chip. Essentially that's how, this is the common name we know it, and IC stands for integrated circuit. Now if you want to push this into a breadboard, how would you do that? Keeping in mind all the shorting problems that you might face, because you see, I'm just going to make a quick illustration here of the breadboard. Say these are our connecting points. Say this is series 1, these are row 2 of my breadboard essentially. Okay, now I need to put this IC. Now if I put it in this way, my pins are going here, this pin is going here, this pin is going here. Means in this row, whatever I connect to any of the pins gets connected to this pin of the IC. But on the other side of the IC we have another pin. We essentially doesn't want this pin to get shorted to this, but when we push our IC in the breadboard in such a way, then both of these pins get shorted. We do not want that, right? I don't have an IC yet, so just please bear with my poor illustration here. So this is essentially the problem that we would face of putting an IC if we decide to put IC on either of the sides of the breadboard. And that's why the engineers and the designers of breadboard have come up with a very simple but very efficient solution of putting a breakage in the series. So what you essentially do, I don't have an IC, so please I'll do that with my pan cap. You put the IC in the middle. So if you just look at from this side, Just hold on, why this is not getting up. Yeah, so if you're just looking from this side, the pins from this side of the IC will get down to these rows, the pins of this side of the IC will get down to these rows. So this side pins and this side pins doesn't get connected to each other, and that's why a break line is made in breadboards. So the illustration depicts it's clear, there is no connection between two sides. So that's how we can put ICs in between. And also there are power rails that comes in breadboards. So they are clearly marked as negative and positive, but that hardly matters. You can positive here, you can keep your positive wire from the battery here, you can keep the negative wire, the ground wire from the battery here, hardly matters. But just for the convention's sake and make it a bit more clear, some of the good manufacturers of breadboards decided to put markers already in current breadboards of the power lines, and they are essentially called power rails. So in the power rails the connections are a bit different. Here all the connections are made along this line. So if you put a wire here and take it to the battery, this whole row gets connected, and this is not widthwise, this is essentially lengthwise. So and same with this. So if you just see illustration here, it just tells you very clearly about what I'm trying to convey here. This whole power line, say this is your positive power line, this is your negative power line. So all the points are connected along this line. So if you put a wire here, if you put another wire here, they are all connected in the same line. So this is essentially about breadboards. I guess I have been able to make you understand a bit of anatomy and exoskeleton and markings of breadboard. Yeah, so good breadboards, I forgot, so good breadboards do come with pre-marked lines. They essentially doesn't help in such significant ways, but they are better to start off with, just to keep a track. If you are making a very large scale prototyping circuit, like back in those days when Steve Jobs and Wozniak did made these things in breadboards, they had to keep track where they're putting all the electronics, because it sometimes get very messy and loads of wires and loads of components get into very big breadboards. So there are breadboards as small as this, even smaller than this. They are called micro breadboards. There are bigger breadboards which comes in more length and more input points and output points. Even I've seen people making whole walking circuits, even a whole computer on breadboards. So they even put 64, 65, even hundreds of breadboards and put all the electronics into it. So this is a very good way of actually troubleshooting and prototyping your projects before you move on and decide to solder them on a perf board. Okay, so that's about breadboards. Okay, so after the breadboard series is over, let's take a look of the next important thing, and that is power source. So power sources actually, they vary from shape to shape, and regarding your necessity, you can use them once you understand this. So I don't have any batteries with me right now. We generally call them as batteries, but just to give a bit of idea about what is the main difference between a cell and a battery. So this thing, it's a mini coin cell. So I have just given a side diagram here. This is essentially of 3 volts. Whenever you go to any China market or any watch manufacturer, you ask for a coin cell and they'll give you a 3-volt coin cell. It's essentially 3-volt coin cell. They also come in 1.5 volt cells. But this one here, it's a button cell and it's actually 3.5 volts. So if you look at the side view here, I guess I have made a good illustration. I can compare it with my illustration. So the bottom side is essentially negative and the top side is essentially positive. If you ask in electronics, in proper electronics, how we notify or signify in drawings, in circuit drawings, and in electronic schematics, how we notify make the batteries. So this is how actually a cell is notified in any electronic schematic. This is a single cell, and when cells come together they form batteries. Just like when cells come together and organisms, they make tissues, and tissues makes organs, and organs make your body parts. So the same way, a single unit is called a cell, and a cluster of cells are called batteries. We move on to the next common power source that we generally see around. We found it in TV remotes, then toys, essentially kids toys, and flashlights, and we're gonna use this most for the next few of our projects. This is a 1.5 volt double S cell. I really doesn't have that in my disposal right now, otherwise I would have shown you. So these are like quick illustrations that I just made right now. So this comes as a voltage source of 1.5 volts. 1.5 volts, 3 volt cell, 1.5 volts cell. So if you may want to make a 3 volt out of this double S cell, you need to put two of them in series. How do you put two of them in series? Like this. You have a battery here. This is the plus side, this is the minus side. Then you put another battery at its back, which is minus, again plus. So plus and minus are connected. You take wires from here, wires from here. This is plus 3 volts, and this is ground. So you have got a 3 volt battery here. Now this is essentially, or else you can put them sideways, which we will do in our projects. So this is the general arrangement that you will find in battery boxes. So this is your ground, and this is your plus 3 volts. If you put them all in a box, if you could make a box, then it's very fine. I've just made another illustration here. This is how a typical battery box looks like. It gives you 3 volts output. You can find them in your local Spark Funtos store or any electronic store disposal. Just go over there and ask for 3 volt battery box, and they'll hand over to you something like this. Another sort of battery is there, and this is called 9 volt batteries. They're very good, but they are current outputs or current ratings are very low. They doesn't go much beyond that 500 milliamps per hour, which means that if they are used continuously for an hour, they cannot output more than 500 milliamps. Milliamps is the unit of current, and voltage is the unit of potential that's there which is formed in between these two units of the battery, between these units of the battery and these units of the battery essentially. So we'll go and explain voltage and current in a short while. So this is about cells and batteries. Now we're going to talk about a very small little colorful object, and that is called your LED, which stands for light emitting diodes, and they come in various colors, shapes and sizes. So I have 3 different color LEDs at my disposal. So we're going to discuss about what LEDs are and how they essentially function a little bit. So this is not boring, I promise you. I'm gonna glow an LED to make it more exciting in the end. So as I said, your LED stands for light emitting diode. Now what is this thing called diode? So diode is essentially a semiconductor. What is a semiconductor? Semiconductor, which is not fully a conductor. So these things are called essentially optoelectronic devices or optoelectronic semiconductors, because when power is passed through them, they emit light, and that's why they are called light emitting diodes or whatever. So they are essentially, since they are essentially related to light and optics, so they are called sometimes in electronics language as optoelectronic devices. So now if you have noticed, each of our LEDs have a long lag and a short lag. And why is that? I have a pretty exciting fun story to tell you. Essentially, what happened was, when I was a kid, and when I was actually, I used to sneak 30 bucks from my dad's pocket every day. I used to steal it, literally. Yeah, don't laugh now. Yeah, I used to steal 30 bucks from my dad's pocket, but I used to I didn't used to buy candies or something. I used them to buy electronic components for me when I was in 6th standard. So I learned glowing an LED in 6th standard, and it was actually a 7-day struggle to learn how to glow an LED. I used to buy around 5 to 6 LEDs almost daily from that shopkeeper, and I used to put them around my 9-volt battery directly, and they used to just blow off, and smokes used to come out, and the fuse used to blow, whatever. So they didn't used to glow, and I was not able to figure out why is that. So one day the shopkeeper asked me that, why are you buying so many LEDs almost daily? I told him that what can I do? I mean, all your these little colorful bulbs are not working with my batteries. They just doesn't glow. He said, show me how you have connected. And I told him that I just connected randomly this to my 9-volt battery, and he said, no, that's not how it works. You see this long lag here? This goes to the positive terminal of the battery, and this short lag, this goes to the negative terminal of the battery. After around say 5 years, when I was studying electronics in my high school, I learned about biasing of diodes. Okay, so yeah, I know that terms really freaks you out a little bit, maybe freaking you out. It freaked me out literally when I was a kid. I couldn't understand, but all I did understood was that this long lag goes to the positive side and this short lag goes to the negative side of a 3-volt battery, not a 9-volt battery, because it couldn't take that much of current or neither voltage. They just blow off that time. So that's what the shopkeeper told me, and that since that time I learned how to glow LEDs, and I incorporated them in all my small projects just for glowing things. And LEDs are very efficient. Why? Because they are very power efficient. They consume very less power, and that's why you might have seen very advertisements coming in television these days about LED lightings in buildings. Yeah, so they come in various shapes. As I told, they come as big as this one, and as small as very small, like just this much. And yeah, actually they are as small as this drawing illustration that I just made. And these are called surface mount LEDs that you see put in small modern electronic boards, and they don't have prongs like this. They just directly solder to the surface. And there are micro LEDs, and there are mega LEDs, and there are high power LEDs, and all that thing. All you need to do, if you need to know more about this LEDs and all, you can always Google it. I'm just giving an introduction here to this. This is something which is reverse of LEDs, and this dude here emits infrared light, so we cannot see it with our naked eyes, so we cannot actually confirm that whether it's working or not. So then how do we do that? We actually do that by putting the battery across the power terminals, across the, as I have told you, the long leg goes to the positive side and the short leg goes to the negative side, and we try to face it towards the camera. And the camera can actually look at infrared lights, and because they have infrared filters in them, and that way you can actually figure out which LED is an infrared LED if they all are of the same color. Essentially they come in this color, or dark blue or dark black. So if you just go and ask a shopkeeper to give you an infrared LED, it's better to keep it in a separate pack, maintain a separate pack, so that it doesn't mix up with other LEDs, because then you have to take each and every single LED, power it up and look it in the camera. So these are LEDs. I hope you'll glow some lights like me. So yeah, I've just used a coin cell here. This is the long terminal, this is the short terminal that goes to the negative side of the battery, and this is the long terminal which goes to the positive side of the battery cell. This is a coin cell, button cell of 3 volts, and this glows.